So thank you, Ovidio and Alex, for the introduction. And also thank you, Incremental Community, for inviting me here tonight. Today, we will talk about progressive web apps and how can we use progressive web app with Angular. We will start from a very generic and high-level overview about progressive web apps, so that even people that are not familiar with this technology can get up to speed with all the other part of the audience. We will see, as I said, we will start with the generic approach, and then we will go deeper and deeper into the technical details. We will see a first demo, how we can turn an existing Angular project into a fully working progressive web apps. And then we will see the limitations or some of the limitations that the progressive web apps have, and how we can overcome these with one or the other approach. But let's start. Let's start talking about what are progressive web apps. Actually, progressive web apps are simply web applications. So if any of you is already familiar with HTML, JavaScript, CSS, actually, you don't have to learn anything new in order to start writing progressive web apps and use them. Because progressive web apps are really just web applications with some extra functionalities and feature that make them not only look like native apps, but also behave like them. So not only in terms of performance, but also as a feeling and the UI, therefore also able to increase the user engagement. Progressive web app, though, might have some extra benefits compared to native apps. This is because nowadays, when someone think about web applications or applications that have to run on mobiles, maybe might be directly oriented to native apps, so iOS, Android, or even both. But unless you have a very, very specific requirements, the same or almost all the same requirements can be achieved thanks to modern technologies and progressive web apps. Progressive apps, though, compared to native apps, has some main benefit. For example, we have, when we develop a progressive app, we have then to maintain only one version, differently from native apps where we have multiple versions live. Progressive apps also allow to have a reduced time to market. This is because we don't have to fulfill all the requirements of the Play or App Store, eventually also having our app, the newer version of our app being rejected for some reasons. With progressive apps, being just a web application, we can deploy to our production service, and we are, since minute one, we are live. They have also a smaller cost of development, progressive apps. This is because we don't need a specified team or even two teams in order to implement the iOS or Android version for our application. Building a progressive web app actually doesn't require anything else than the know-how of our web development team. Therefore, we can reuse the same know-how or the same team we have it already in. Another aspect is that progressive apps tend to be lightweight by nature. The size, for example, of Twitter is much smaller than in the progressive app version than its counterpart native app, so Android or the iOS. So these are some of the benefits that the progressive web apps can provide. So keep in mind that might be also a good thing to start looking into progressive app and not jump straight into native apps. Good. That said, let's start and let me first introduce myself. As though Alex and Ovidio already did, my name is Francesco Leardini, and I work as a senior consultant at Trivadis. Recently been acquired by Accenture, and my company headquarters, at least my region company, is in Zurich, Switzerland. I work as a full stack engineer, so having also a backend side, C# and .NET, but I really love front end and especially Angular. Therefore, I really also for my personal project put a lot of effort in learning more and more about these technologies, and of course also progressive web apps. But let's start now thinking about a very concrete example. where progressive apps are really powerful. Let's imagine we are commuting to work or simply traveling from A to B place, and we are looking our best blog site, technical website. And then we are traveling and then going from one path to the next. This is what we often occur, especially if the network connection is not so good, not a very good experience. But progressive web app can allow us to provide in a very easy way customized offline pages. Eventually, we can provide through these customized offline pages some company static data, phone numbers or images, promoting some marketing campaign going on. Therefore, not only the user recognizes the color and the logo of our company, so therefore is a much better experience than simply the offline dinosaur that he or she would eventually get. But also we can, even when we are offline as a user, we can still get from the web app some useful information. In some other cases, like here on the right side, the Trivago, we can even go further and provide an offline game in order to keep the user attention locked on the web application until the connectivity is then restored. This is a very cool trick if you think about it, because by keeping the user entertained with this simple yet interesting game, then we keep the user on our website. And then as soon as the connectivity is restored, the user is online again, then we can redirect the user to the wished or requested originally page. In this way, we can retain a possible customer or new client that otherwise we would have more probably lost. And all this is possible with progressive web apps. I say that the progressive web app look like native apps, so they have some extra benefit. For example, they are very lightweight. Here are the Twitter version of Android is a screenshot of my phone, and the relative progressive web app. As you can see, once installed, because progressive web app can also be installed on the target device, once installed, there is not really a big difference between them. If we open them, we can see indeed some colors, some layout elements are different. But again, I leave you now a couple of seconds to try to guess which one is the native app and which one is the progressive web app. Not very easy, because except some details, they look exactly the same. And this is also one of the goals of progressive web app. But now I give you a small subtle hint. This is the size that on my phone, the Twitter takes on my phone, and you can maybe guess that which was the native app and which is the progressive web app. You can see the memory footprint is extremely small compared to a native app. But again, layout-wise, almost the same. And this is a very nice thing of progressive web apps. That's it. So having started describing from a very generic level progressive web app, let's start going deeper into the technical aspects, and let's start describing which are the core components that make progressive web apps so special. The first one is the web manifest. Web manifest is just a JSON file that defines how our progressive web app should be rendered once installed on the user's device. Here listed, there are some of fields, not all, but these fields are mandatory in order to let the agent pop up the add to home screen dialog that allow the user to click on it and having the progressive web app installed on a user device. Aside these mandatory fields, also a service worker that we will describe in a short time, has to be up and running and installed on the user device. We can see that starting from the top, we have to define a name and a short name, and these will be used once we install the application on our device. A short name is a fallback in case we use it for the name property a value string that is too long. Display is another very important property. There are three different values that we can use. Browser is not very interesting because this is the default experience we get when we access a web application, a website with our mobile device. We can see that all the UI elements of browser are there. Standalone is already more interesting. We can see that address bar of the browser disappeared. And also, when we define a display standalone property for our progressive application, PWA, this will be open in a separate tab, indeed standalone. So not anymore as a tab of Chrome, but a separate independent tab, as it would be indeed a native app. We will see later in the demo how does it look like. Full screen, as the name suggests, will take the whole device screen. And this could be a good value for applications that are rich of media or eventually a web app game. Start URL allow us to define which is the starting point of our application. This is because we want to give always a feeling of a native app through our progressive web app. So we want that every time the user accesses our PWA, he or she will always land on the same homepage, dashboard, but anyway, always on the same starting point. We don't want that the latest visited page will be opened. This because it helps creating or increasing the engagement and familiarity with the application. Icons is a property array that accepts a multiple set of icons. As a minimum, we have to provide 2 with a 192 and 512 pixels square size. And then the browser will be responsible to scale according to different target device that the user is using. But it's always good to provide multiple sizes in order to provide a pixel perfect experience. If all these settings or properties are properly defined and there is a service worker running already, we will see once we access our web application website that is powered with the progressive PWA features, we will see at the bottom of the page the so-called Add to Home Screen dialog. By clicking on it, we will install the application on the target device, indeed on the home screen. We don't have to know by heart all these properties. There are some manifest generator. One of them, the link is in the top right corner of the slide. And you can go and fill a form with all your values and then simply let the portal generate the JSON file for you. Among other optional, but still recommended properties are, for example, the possibility to define the orientation of our application. So whether we want it to be displayed in a portrait on a landscape mode. That depends on your requirements. In the manifest file, aside of these properties, we can also define so-called shortcuts. Shortcuts, in short, are just a link to an URL pointing to any page inside our progressive web app. They are typically used to group common actions or important pages within our application. And once again, once the user interacts with the icon of our PWA, in this case with a long press on the icon, here is the example of Twitter PWA. So we are activating this shortcut menu, and we can then select one of these items. And then we can go, for example, in case of new tweet, we can go straight on the page where we can compose, in the case of Twitter, a new tweet. This is just an example, but so very useful to show you what we can achieve with progressive web apps and how we can provide the feeling that we are dealing and we are using not really a web application, but the more we look at it and the more it sounds, it feels like a native app, with all the benefits though that we've listed before of progressive web apps compared to native apps. Service worker is the other core actor of progressive web apps. Service worker is like or is a web worker, but with a specific task to act, to work as a proxy between our application and the network. Is capable of intercepting all the traffic from and to our application. Because of this, though, it has to run, otherwise it won't work, behind a secure connection, because we don't want to leave any possible man-in-the-middle attacks by doing this and by acting as a proxy. It's considered no blocking because as a web worker, it does not run on the same thread as our main application. And this is good because if the service worker for any reason is running a very heavy task, therefore is slow for any reason, or eventually it crashes, we don't want that this will affect in any way our main application. How the service worker acts, or how does it work? When we access our web application the first time, we get the response, and we also downloaded the service worker file that is just a JavaScript file. This service worker, according to how we implemented it, how we define its logic, might already eventually cache some assets, JavaScript files, images, or even HTML files in the local cache. From that moment on, even if we don't have an internet connection at all the following requests will be intercepted by the service worker. And then if the service worker finds that there is a match between the requested assets or the requested response in the cache, then it can delivers it from the local cache. This has a double benefit. Not only we can provide and give data to our user when they are totally offline, because as you can see, we don't need to go over the network. But also we can provide this response in a very, very efficient and very fast way because they are already on the client side. Everything starts by registering a service worker. This is done by invoking the register method. And there we have to define where is the physical file of that compose, that implements our service worker. The scope parameter is optional, and we can use it to specify eventually a subset of our content that we want the service worker to control. It's optional because if we omit it, then the scope of our service worker is the position where it is and all the children path or children folders. That's why usually the service worker file is placed at the root of the domain. This allows the service worker scope to cover the entire origin and to allow to receive fetch events from everything on this domain. However, the service worker per se, we saw, is capable of caching some assets by intercepting or simply by installing it at the beginning according to how we implemented it. But we have to tell the service worker how and what has to be cached, because by default, the service worker doesn't know that. And this is possible thanks to different caching strategies that we can implement in order to cover different scenarios according to what are our requirements and our needs. This is very important because mobile traffic constantly increased in the past years, and even to cover all the accesses that have been done through desktop devices. Therefore, it's very crucial being able to optimize our web application also for mobile devices. Actually, nowadays, we tend to be more oriented towards a mobile-first approach, or at least this should be the case whenever possible, of course. The first strategy we will describe is called the cache-first strategy. And this is also used when we want to build an offline-first approach. As the name suggests, every time the service worker intercepts a request, first it will check whether the data is available in the cache using the cache API. And if not, then it will fall back to a normal call. So by implementing these strategies, then we can tell the service worker while it's installing to already cache some data. And then, since some data, typically assets that compose our core application shell, so the minimum asset style that provide a minimum layout or eventually even the offline page, can be already present in the cache just before the service worker is active and running, so that all the following requests might be served even when the user is offline, because the service worker can find them in the cache. Another, actually opposite strategy is network first. Again, the name is quite explicative. We want to go first over the network because we want to provide very up-to-date, very fresh data. And only if the network is not available or because it's very slow, therefore we can define a specific timeout, then the service worker will redirect the response from the cache, of course, if the data is available. This strategy might be very useful when we want to provide responses for assets that are fresh, crucial. For example, we want to provide the very latest value of a stock exchange market. In that case, then this strategy might be very indicated, very good. In case then we provide the data from the cache, so we have to remind that we should better inform the user that the data they are visualizing is not the live data, but is a stale, so that is coming from the cache, if the freshness of your data is critical, of course. Aside these, that are the two also only at the moment caching strategies that Angular is also offering and implementing, there are other strategies that we can implement, so they are not coming out of the box with Angular at the moment. One of them is the stale while revalidate strategy, and this is a kind of a hybrid of the previous two that we saw. With this strategy, we provide, once we intercept through the service worker, we intercept the request, we provide the data from the cache. Therefore, we can offer a very fast response. But then, in the meantime, the service worker goes over the network and checks whether there is a more up-to-date version of the requested assets or response. And in that case, if there is a match, a newer version is available, then downloads and updates the cached version. This has the benefit that next request intercepted by the service worker will be delivered with a fresher data, so more up-to-date data from the cache. To implement this strategy, we need a little bit more code. Again, it's a very simple, it's not very complex. We have to go over the network also in case, not in case, but in parallel after serving from the cache. But there is a little bit of code we have to write. However, thanks to some modern libraries, we can avoid and wrap all this complexity through or using some libraries like Workbox, for example. Workbox is a set of libraries and node modules that make it very easy to cache assets and implementing caching strategies, abstracting all this complexity as we just saw. For example, if we wanted to implement the stale while revalidate strategy that we just saw, again, not many lines of code, just 16 more or less, but still some, we can just do it in 1 or 2 lines of code with Workbox. It provides a set of methods we can invoke and then defining a route, so a regular expression that will target specific files. In this case, here we want to cache JavaScript and CSS files, so just static files. And then, as a second parameter, we can define the stale while revalidate strategy in order to cache them. Again, 1 line of code, done. But we are interested in Angular and see how Angular can also help us to implement progressive webs. Since the version 1.6 of Angular CLI, we can, thanks to the Angular add schematic with the Angular, so with the ng add at Angular PWA command, we can turn an existing Angular project into a fully working progressive web app in a very easy way. Let's see now our first demo and how does it work and what this command does to our application. So here, not that. Let me switch that. Great. Okay, well, we will look like this. Good. So when we invoke that method, in this application, that is an existing application, I already invoked this Angular add PWA schematic in order to gain some time. What this command does for us, first of all, it will download and install the service worker module in the app module for us. And again, it will invoke the register method by passing the physical Angular service worker file. This file, if you look into your solution, you won't find it because it is placed inside the node modules. This is also another aspect or how Angular deals with the progressive web apps. At the moment, this service worker is a kind of a black box for us as developers, because if we go in the node modules and we change this, then all our changes will be wiped out when we make a new build. So there are some possibilities that we can implement in order to have some custom code within the Angular service worker default file, but these need some extra work. For example, we can create a base class that imports both files, our custom service worker file and the default one, and then in that case we can add some extra logic. But for what I've seen, in many cases, this approach is already enough for many projects. And this service worker will be up and running and registered when we made a production build. This command also creates and register in the index.html a manifest file, as we saw before, so we don't absolutely have to remember all the different properties. These properties are filled with some default values with this command. Of course, then it's up to us customizing according to our needs. And as you can see, we have multiple values or multiple sizes of the, in this case, it will be the Angular logo that automatically is downloaded and provided as asset for us by invoking this command. But much more interesting in the Angular service worker configuration file, because it's here where we can define which are the static assets we want to implement and eventually which are the caching strategies we want to use in our application. By invoking this schematic command, this is what by default is created. We create, or the command creates an asset groups array where we can have a prefetch install mode and install mode lazy. What does it mean? The first block, the first object, targets a set of files. These are the static files that, as we saw before, will be prefetched. So while the service worker is installing in his life cycle, so is getting installed, he will prefetch, so it will download all these files and install in the cache. So here we can define all the files that we want to be available in the cache as soon as the service worker is installed. We have to keep in mind that if we put here too many or very, very heavy files and the service worker for any reason fails to fetch them during this phase, then the whole installation step will be aborted and we won't have any service worker installed on our side. The service worker will try again with a page refresh, or next time the user will access our web page. But we have to keep in mind that. The other object that is created by default targets files that are not so important. So, for example, the font files and the assets, so images and so on. And because of this, we use an install mode lazy. That means that the service worker will cache these target files only after they have been requested at least once. And then update mode prefetch means that it will then see if there is a newer version once requested again on the server, and then update that very specific version in the cache if there is a newer one. In that case, we could have also used lazy here too as an update mode. In that case, then we would not, or the service worker would not eagerly check if there is a newer version, but it will just refresh the cache version only if these assets have been requested again another time. So these asset groups property is created by default and targets static files. However, we can also provide another property called data groups, also is an array, and here we can define all our target URLs, and for each of them we can find a different caching strategy. In Angular, the cache first strategy we saw before is called performance, and the network first strategy is called freshness. These are at the moment the two available cache strategies we can implement on our side. So we can define, we give a name to the cache, and then we can define which are the target, the URL that we wanted to cache. In this case, we cache the responses from these coming from this URL. Then we can define how many entries we want to keep in the cache, 5 in this case, and for how long, 15 minutes in this case. Performance is good when we are not worried that the data that we provide from the cache might be stale or actually not the very latest version of it. We are more concerned of providing a very, very fast response, because indeed all what it comes from this cache is locally, so it's very fast. The other block, the other cache that we will use strategy freshness. Therefore, here, in this case, is endpoint providing random cat's image. Here we want to have always, at each request, the very latest cat photo. And then again, we can provide how many entries we want to keep, for how long we want to retain, and here important is a timeout, so that we can define for the freshness strategies a timeout, so that if the response takes longer than 5 seconds, then the service worker will provide the response from the cache. Of course, we can increase or reduce this response time according to how do we want. But this was to show you how we can cache static assets and eventually even responses. And the data groups is the only thing I had to add extra from this schematic command to turn a progressive, an Angular project into a progressive app. And all this can be done really in a matter of minutes. But let's see live, how does it look like? So this is our application. We can see if I refresh, the joke remains. This is using the performance strategy, and just provides the response or a random dead joke from a website. On the other side, we can see every time we refresh, we get always a new cat photo, because we're using the freshness strategy. If we open the DevTools tab, we can see that in the application tab, we can also in the application area, we can see here in the manifest all the properties of the web manifest, plus if there are some errors we can debug, or we can see here if something is not set up correctly. But most importantly, in the service worker area, we can see that is we have a service worker up and running, and everything looks fine. Now, the network tab shows us that the search, the dead joke, let me increase maybe a bit. The dead joke is coming from the service worker, so cache, so there is no network traffic at all for that. While the image, the cat image, is coming from the network. Now, if I go offline and I refresh the page, we can see that everything is here again. Not only the static assets, images, color, fonts, and so on, but also the response from our two services is provided here. And actually is also quite fast, if you see, because everything is coming from the cache. Now, we are still offline. We can see that our responses are both provided from the cache. If now I go back again live, refresh the page, we can see that we will have a new cat photo coming from the network, and everything looks good. We can see also that we have at the end here an Angular service worker JSON file. This is very important because, let me enlarge it, because this is what the service worker uses in order to check whether there is a newer version of it. In this file, there is a hash table that has different values for each of the assets we stored in the cache, so that it can, if anything is changed, we can then infer that there is a newer version, and this very specific version will be downloaded. I want also to show you a very nice extra feature, a kind of a parachute, let's go like this, feature. If we made some mistakes and we wanted to wipe out the cached version and the service worker and everything from our clients, because maybe we deployed by mistake a buggy version, we can delete from the distribution folder, we can delete this Angular service worker.json file that is also generated while we do a production build. So I now deleted it. Yes, I'm serving the application from this, or serving it through a web server from this specific folder. And this is important to mention because you cannot use ng-serve with a service worker. You need to use in this case, I'm using HTTP server, for example, or you can use any kind of web server you like in order to serve these static assets, because otherwise the service worker doesn't work with ng-serve. Okay, we deleted that. Now we do a refresh, so we should not being able to see anymore the Angular service worker file, but more importantly, now we should see that as soon as the service worker detects that we don't have that file anymore, we should see that the service worker, is deleted. You can see here, aside. And if we go in the cache storage, that's empty. So this is a kind of, let's call drop a bomb or parachute measure that we can enforce in case we deploy a faulty, buggy version of our service worker. Aside that, what I wanted to show you is how really easy is to turn an existing web project into a full-fledged, full-working progressive web app with Angular, with just this command. Here you can see the URL to this very specific demo that we saw. You can fork it or just play with the live demo, and the code also is available there. One limitation to mention, though, that we saw before, that the service worker uses the cache API. This allows us to cache the response of GET calls. This is fine for passive web applications, where we simply derive data, but in many cases, we also need to allow the user to edit and create some content. And the cache API does not allow to cache post or put calls. So how we can overcome this limitation? One possibility is to implement the background sync API together with the IndexedDB. So this sync API or background sync API allow us to defer some action until the user has a stable connectivity again. For example, we can implement this construct for storing or a very long post form data, so that in case the user fill all the forms, click on the submit button, and instead of getting a server error or an error that he or she is offline, we can store all the form data into a local IndexedDB and then register a synchronization, giving it a specific name. In this case, is a post form. If the network connection is available, then the sync action happens immediately. While if the user is offline, maybe is going through a gallery and so, and just in that moment, click on the submit button, then the sync action event will be postponed until the connection is restored again. And this is also done completely offline or completely in a separate way by the service worker, even if we close the application, because the service worker runs on a separate thread. So this synchronization happens through the service worker, even if indeed the application is closed. So we can keep all the pending requests in the IndexedDB, and then as soon as the service worker detects that we are online and this sync event is triggered, we can then go over these pending records in the IndexedDB and trigger them one by one. It's also possible, not very complex, but there are other alternatives. One of them is using the offline persistence of or provided by Cloud Firestore. Cloud Firestore is a NoSQL database belonging to the Firebase platform. It's a collection of services and tools provided by Google that we can use to implement mobile and web applications. In this case, we are interested in the web version. Once we downloaded the Cloud Firestore library, only thing we have to do is to initialize with some API key values and some other configuration values. But aside that, we just have to initialize the Firestore and call the enable persistent method. From that moment on, Cloud Firestore will cache every document, so any record that will be sent it back by the NoSQL database and stored locally into an IndexedDB for us, making it also available while we are offline locally, so that we can still interact with these documents or these records in Cloud Firestore environment. The documents of the database are called records, and then we can create new ones, we can edit existing ones. And all these pending offline changes will be collected, and then when we are online, automatically Cloud Firestore will detect these pending changes and propagate it to the server and updates into the server, into the database, and also to all the other clients that are connected to the same database. This is done thanks to socket connections. But let's see now our second demo. And with this demo, I would like to show you another aspect, another power of Progressive Web Apps, the possibility to turn our web application into a full seamless application that is capable of working online and offline, no matter the state of the network of the user. So the user won't have any perception of being online or offline. For that, I will use also my phone. This is a personal project of mine where I keep track of all the nice restaurants, bars, pubs, and so on that I visited while traveling, and then suggesting or actually suggesting to avoid to a friend of mine if it is not good. If we open the application, the PWA that I have installed on my phone, indeed, as you can see, all these 4 applications I implemented that. All these 4 are Progressive Web Apps, and they look like exactly as all the other native apps. If I open it, we can see that my PWA is provided, since I use the display standalone, is provided in a completely separate tab, as it would be a native tab. Aside that, is also very interesting that if I go in the installed applications, I can see that here at the bottom, the Android says that this app has been installed from the Google Play Store. This is actually not true. But when we install our Progressive Web App in an Android device through Chrome, then out of the box, a web APK is created for us. And this gives us a lot of extra benefits. One of them is, for example, being able to list our PWA in the native apps, installed apps in the device, so that as it would be a native app. Plus some other benefits. For example, if we request the URL that is within the scope of our service worker, then automatically the PWA will be opened instead of the browser. So very interesting. But let's go back to our demo. Another thing is that we can see that it's responsive, so we have only 1 card per line. Now, let me open it. Let's still from the previous presentation, the offline the title. Let me take it out. I save it, and we can see that automatically the changes are propagated. Now, here, this is the other client that is connected to the database, got immediately the changes. So it's all very reactive and very responsive in terms of getting this data without having to do any polling or any refresh. And now comes the very nice thing. I go offline. So let's imagine I'm traveling with my phone and I'm in airplane mode, so completely detached from the network. Now I refresh the page, and as I can see, I don't have the images anymore. Let's do it again, because I didn't cache them before. At least I have to cache them once. I have the different static assets, so styles and so. Let me refresh it again. Now they should be cached. I go offline again. Good. And now I refresh again. Now these also images have been cached through the response. And therefore, they are also, while I'm offline, we can see the airplane icon up here. So even offline, they are available. But now here comes the cool thing. If I open a completely new place, I remove the offline from the title, I save it, and even I get a new one, let's say this one, and I write edit it just for the sake of demo, and I save. Now, we can see that we have here on the right side is my phone. I have edited extra in this record, in this document, and I removed the offline from here. While on the left side, the client that is listening, that is online and so, of course, didn't get these updates because they are here already on my side, because I'm offline and I cannot synchronize those things. But now I will remove my airplane mode, and the Cloud Firestore automatically will detect these changes. And what I would expect, I will leave the phone so I no chance to cheat. I would expect that these changes will be propagated on the left screen, so on the server, and then all on the to all other client listening. So let's remove it. Hands up. Let's see that according to how fast is the network. Yeah, quite fast. So we could see that immediately, or almost immediately, the changes that I did in the specific to these two entries have been propagated to the server, to the database, and then to all the other listening clients. This was a demo to show you how we can, with modern technologies and tools, and with Angular, how we can, and progressive web apps, of course, how we can create an application that is working online, of course, but even if the user is offline, he can still, or she can still, changes the records, updates, delete, create new ones, and the application simply works. Then as soon as the user is online again, automatically, or I like to say auto-magically, these changes are synchronized to the server and to all the other clients. So for the user, actually, there is no perception at all that he or she is offline. And with that, we reached the end of the presentation. I leave you here some links where you can dig deeper into some examples or some extra information about progressive web apps. Again, here the repo and some social link of mine. So if you have any question, do it now, or you can always contact me later on. If you would like to get updates about web news, progressive web apps, and so, feel free also to follow me on Twitter. That's it. Thank you very much for your attention, and thank you very much, Alex. Also, I give you back the word to you.
Okay, thank you, Francesco. I was curious about the these web apps. When is not the time to use them? Because I'm sure there are some they are great and you can have a lot of speed in developing, but when is not the case to use a PWA?
Yeah, this is a very good question, because we might get all excited and we dig into it, but we have to also say what are the limits, not only what we saw. One big limit is that if we need web notifications, nowadays this is not possible on iOS devices. So there is even a petition going on, but this at the moment is not possible. So if for us being able to implement an application where it's crucial to reach not only Android devices, but also iOS devices through or with web notifications, then we have to either fall back to SMS for those devices, or otherwise we have to go on for a native app. We cannot on iOS devices deliver any web notifications yet. Another thing to keep in mind is that native apps are tied, are very tied with the operative system. Therefore, in terms of performance, they can do much better in terms if they have to do something very heavy or some very complex logic. Then of course they can do better than PWAs, because progressive web apps at the end are just web application. Therefore, they are run through a third-party browser. Therefore, this might introduce eventually some latency that we have also to keep into account. And then also we have also to keep in mind that the progressive web app can do only what the web can do. This means that, for example, a native app can easily let us reach the agenda or the contact list of our device, mobile phone, for example. This is not possible with web, even though there are some experimental APIs belonging mainly, or not mainly, belonging to the Fugu project from Google. One of them is called the Calendar Picker API. These, even though experimental, allow us previously requesting a permission to our user, but allow us through or with a web application to access the contact list of a mobile device. And this was so far not really possible. So there are attempts to shorten and to close this feature gap with native apps, but still this would work only in experimental way and only on Chrome devices. Therefore, this could be another limitation. These are the main things I would consider if I have to decide between the two.
Okay. I remember, I don't know, a few years ago, when I worked on some project, they were doing a proof of concept, and in an application, it wasn't progressive. It was with Ionic or something like that, and the app was moving more slower than the native one. Is this a characteristic of PWA as well, or the movement it's okay?
No, in that case, I would say it was something with Ionic. I had to implement recently in some clients project exactly a web version that even with the Hammer.js, so with the swipe movements and other kind of transaction or touch gesture that are very useful, are typically used in a native app, and I had absolutely no problem, no delays at all. So maybe it was coming from Ionic, but I don't have too much experience with Ionic, so maybe someone else can say, no, Ionic nowadays is super great, but I cannot say much. But with progressive app, I didn't see any delays in that sense so bad.
Yeah, maybe this is a challenge for who is not who does not agree that Ionic is slow. Maybe he can be the next speaker and show,
Sure.
hey, Ionic is great.
Yeah, that would be very interesting, isn't it?
Just a moment, because I think we have a question in the Rocket. I have another screen here. How does the service worker know that I updated the version of an asset? So how does the service worker know that an updated version of an asset is available remotely, so he can download it and cache it?
Yeah, as you can see, every time before I saw the first demo, every time we make a request or every time we access the page, there is this Angular Service Worker JSON file with this hash table that is downloaded. This is done every time. If it's not, then the service worker on the Angular side detects that there is something wrong and deletes all the cache. Otherwise, every time this let's say, I downloaded the service worker with this set of hash table values. And then in the meantime, in the night, a new version, a new asset has been updated. So on the server, when I access, for example, tomorrow, I will download again the Angular Service Worker this JSON file with the hash table, and the service worker will detect that for that specific asset, the hash value is different. Therefore, he understands that way, okay, this is different, and will replace it in the cache. So will update it in the cache. So this is something that constantly will be downloaded in order to inform the service worker which are the current states of the assets.
So it's a hash-based solution.
Yeah.
Okay. Thank you, Adrian, for the question, and thank you, Francesco, for the explaining. I think this is it from my side, and I think this is it for this evening. Ovidio is here again with us. I want to thank you again, Francesco, for being with us this evening, and of course, I want to thank you, Ovidio, for helping, and EPAM, of course, for helping us host this event.